Hello everybody. In this lesson, I am going to tell about the reaction intermediates in a chemical reaction. In the previous lesson, if you are following the lesson number 1 to 3, you will come across that reaction intermediates, how the reaction intermediates have been formed. What are the different reaction intermediate you come across in the organic reaction? If the cleavage takes place homolytically, you are going to end up with the free radicals or carbenes. If the reaction takes place in a heterolytic cleavage, then you are going to have a carbanion and also you are going to have a carbocation. So these are the different types of reaction intermediates that you come across in a chemical reaction. So those reactions may be carbocation, carbonium ions, or we are also going to call them as carbanion, carbon free radicals, carbenes. These are the different reactive intermediate you come across in organic chemistry. So depending upon the type of the cleavage, depending upon the type of the intermediate that you are going to get, the different products may be obtained at a different rate and the reaction path, the mechanism will differ. Therefore, the type of the intermediate that you are going to get, depending upon the type of the cleavage, that play a very important role in the formation of the product. The reaction intermediates, these are the species which are produced during the reaction but are lost before the formation of product. So those reactant, their lifespan is very short, they are highly reactive in nature, that's why they are called as reaction intermediate. During the reaction they are going to come as an intermediate and they are going to form when the old bond is broken and they have been disappear before the product has been formed. Heterolytic or homolytic bond fusion result in the formation of the short-lived fragments called as the reaction intermediates. Among the important reaction intermediates, carbocation or carbonium ion, carbanions, carbene free radicals and carbenes are there. Apart from this, there are other intermediates, but since we are concerned only about the organic, therefore with respect to carbon, similarly you may have the nitrines and other reactive intermediates, but here I am concerned only with the carbon related intermediates. The first one is carbocation or carbonium ion. The cation which is an ion, as the name indicates, it's a carbocation. It is a carbon which is going to carry the positive charge. So such positively charged carbon atom we are going to call it as the carbocation or carbonium ion. So this is the shape, it will be like this. It's going to have only 6 electrons. It has the electron deficient. It has 6 electrons in the outermost shell. So it has been formed by the heterolytic cleavage. It has been formed by the heterolytic cleavage. The cleavage of the methyl chloride, when you consider the methyl chloride, when it cleavage heterolytically, the bond electron, since the chlorine is more electronegative in nature, the chlorine will going to pull the electrons from the carbon between the CCl bond. The Cl is more electronegative, that's why it going to pull the electron, thereby it going to carry the negative charge on that, and the carbon will, since it has give away its electron, it going to carry the positive charge. Such intermediates we are going to call it as a carbocation. Since it's a methyl, therefore this is called as a carbocation. There has only 6 electrons in their valence shell. They are going to act as a Lewis acid. So they have a tendency to accept the electrons and they are electron seekers and they are highly reactive, and carbocation combines readily with any substances that can donate a pair of electron to form the bond. Now CH3 plus will immediately react with OH minus to give CH3OH. Similarly, these carbocation, depending upon the nature of the carbon present in them, they are classified into primary, secondary and tertiary depending upon the class of carbon having the positive charge. If a carbocation having the carbon having the positive charge with 3 groups attached to it, if it is a tertiary carbocation, carbon positive charge, if the positive charge on the tertiary carbon, then it is called as tertiary carbocation. Tertiary carbon is a one which going to attach to 4 different groups attached to it, that is called as tertiary. If 2 different groups are attached, then it is called as secondary. If only one CH3 group is there, it is called as primary. No CH3 group, then it is called as methyl, depending upon the type of the groups attached to it. Your carbon is the one which going to carry the positive charge, is electron deficient. For that, the different groups have been attached. If only hydrogen is there, then it is called as methyl. If one hydrogen in the methyl carbocation, if it is replaced by the R group like CH3 group, then we are going to call it as a primary. If it is replaced by 2 groups, then it is called as secondary. If it is replaced by 3, then it is called as tertiary carbocation. Similarly, carb anions. Again, why we have to do the classification? Because primary, secondary and tertiary carbocations, they are going to behave in a different manner. They are going to react with a reactant. Since these are the attacking reagent, they are going to attack the substrate in a different manner. Primary will going to attack in a different manner. Secondary will going to attack in a different manner. Tertiary will going to attack in a different manner. Leads to different product. And also the rate of the reaction mechanism path will differ. Therefore, the classification play a very important role. Second intermediate that we come across is called as carbanion. Carb anion. It is the anion present on the carbon. Therefore, this is called as carbanion. Negatively charged carbon atom, we are going to call it as a carbanion. This is a carbon which is going to have excess of electrons in them. This is also formed by the heterolytic cleavage. The cleavage of an organic metallic compounds, organometallic compounds takes place, resulting in the formation of the carbanion and positively charged metal ion. So you are going to have CH3 minus and Li plus. These are 8 electrons they are going to have in their valence shell. They are Lewis bases and they are nucleophiles and they are very reactive, and they readily combine with the species which are electron deficient to form the 4th bond, which is going to accept the pair of electron. What they are going to have excess, that will be accepted by the species. It will going to react. Again, they are also classified as primary, secondary and tertiaries based on the same parameter how they have been classified with a carbocation. Depending upon the type of the groups it has been attached. The carbon having a negative charge, if it is attached to 3 hydrogen atom, then it is called as methyl. If it is attached to 1 R group and 2 H group, then it is called as primary. 2 R group, 1 H, it is called as secondary. All the 3 are R group, then it is called as tertiary. With the same reason, the carbanions, if it is a primary, secondary, the attacking nature will differ. And the third intermediate that we come across is carbon free radicals. These are the odd electron neutral species. They do not carry either a positive charge or a negative charge, but they are going to have odd electron in them. Such species are going to call it as free radical. These are obtained by the homolytic fission, homolytic cleavage. Generally, these reactions takes place in the case of vapor phase, and also when you do the ultraviolet radiation, when you do the photochemical reaction. So chlorine is there. Chlorine, when it undergoes the cleavage, homolytic cleavage, it is going to give free chlorine free radical. Similarly, methyl chloride methane will react with a chlorine free radical to give methyl free radical. These reactions play a very important role because this is the part and parcel of the reaction that has been taking place in the ozone layer depletion. Photochemical reaction and homolytic cleavage is there, and the ozone layer for this is type of cleavage is taking place, and this is very important aspect in order to understand how the ozone layer depletes. Similarly, these carbocation, depending upon the nature of the carbon present in them, they are classified into primary, secondary and tertiary depending upon the give a pair of electron. Again, these are also classified as primary, secondary, tertiary on the same parameter in which it is going to have how many number of R groups based on. These are 8 electrons they are going to have in their valence shell. They are Lewis bases and they are nucleophiles and they are very reactive, and they readily combine with the species which are electron deficient to form the 4th bond, which is going to accept the pair of electron. What they are going to have excess, that will be accepted by the species. It going to contain 2 valence. Carbons may be generated by the elimination reaction in presence of a strong alkali of the chloroform. So chloroform, when made to react with the RO minus, you are going to get the ROH. First case, what happens? H will be removed and you are going to get Cl3C minus. In the same molecule, when you Cl3 C minus. When you remove one more carbon atom, one more hydrogen atom, you are going to have Cl2 C. One more chlorine atom if you remove, then you are going to have C2C. These are called as dichloromethane. Otherwise, it also obtained by the diazomethane or ketone in presence of UV radiations. Sorry. And carbons can exist in two forms. One is called as a singlet form, other one is called as a triplet state. Whereas in a singlet state, you are going to have the odd electron. If the odd electron shift is present, the same lobe of the sp2 hybridized, then we are going to call it as a singlet state, and they are less stable. Or it may be present in the triplet state, which is more stable. It is in the sp hybridized. So you may have the carbon which is going to present at the center of the carbon. It may be either sp2 hybridized or it may be sp hybridized. If it is sp2 hybridized, it is going to have only one sp2 hybridized lobe that going to have both the electron, that we are going to call it as a singlet. If it is present in the central carbon atom, which is in the sp hybridized, means it is going to have two bonds and it is going to have two sp hybridized lobes, sp hybridized orbitals. Though each orbital, if it has one electron, they have to call it as the triplet state. Thank you. All the best.